Let's start with some facts. We live on the Earth, a giant ball of rock hurtling around the sun at the immense speed of 66,000 miles per hour. You are watching a non-fiction film. We are all going to die. India is going to split in half. So now you're probably thinking, oh my god, I didn't know 2020 could get any worse. Don't worry, Armageddon will probably pop up before this happens.
A piece of rock just 6 miles wide changed all that.
Anyways, you're now looking at a scale model of the Earth. How in the world do we know that India is going to split? When is it going to happen? What's happening? Who did this? Why? It is the 8th century. Homer is writing a book. People think the world is flat. Let's skip all the mumbo-jumbo that happens next and skip to 1521. So now the Earth is round. Magellan travels around the whole world and says,
"Hey, it's always been this way. These land masses are fixed."
And then he gets shot by a poison arrow after trying to convert the natives to Christianity. But then, in 1591, Abraham Ortelius, a Dutch map maker, says,
"Wait a second, this whole Earth looks like a puzzle."
Then he says some poetic stuff about the Americas being
torn away from Europe and Africa.
Yada, yada, yada. Well, everyone hates his theory since people only believe in catastrophism, that everything on the Earth happens by a bunch of catastrophes from God.
One thing I can't stand is people groveling. Sorry.
So now we've skipped through another couple hundred years, and it's 1858. A French geographer named Antonio Snyder Pellegrini writes a book called Creation and Its Mysteries Revealed, and says,
Well, you see here, I found these fossilized plants growing here, and that's not possible unless the world was all together.
This is the first beginnings of actual proof. Remember Ortelius? He's dead now, but it's 1912 and his idea is coming back. A German meteorologist, Alfred Lothar Wegener, says that 200 million years ago, Pangaea broke. He bases this on scientific analyses before him, saying,
"Hey there, South America suspiciously fits into Africa. Plants can't swim, so they must have been connected by ground, and there's no way dinosaurs swam that far. Let's call this continental drift."
And then he froze to death trying to cross Greenland. The scientific community fiercely debated Wegener's ideas until the 1950s when several new discoveries essentially proved him right.
Round one, fight. Liu Kang wins.
What changed? First, we started looking at the bottom of the ocean. You can observe this now if you look at Google Earth and the ocean ridgelines. Back in the 50s, however, they could see these ridges with early versions of sonar that measured the depth of the ocean. They found something called the Global Mid-Ocean Ridge. In the 1950s, they also started using magnetometers and started recognizing magnetic variations on the ocean floor. These patterns became apparent through symmetrical magnetic striping, with each strip of rock having a different magnetism. Also in the 1950s, through petroleum exploration, research vessels drilled holes at specific locations. These ocean floor cores showed that the ocean was indeed spreading. Throughout this time, the seismograph is taking off and people are recognizing patterns of prominence among seismographic activity. These were called the Wadati-Benioff zones. At this point, tectonic plate theory is canon now in the story of Earth. So let's recap. The world was thought to be a flat disk and everything was fixed. Then people were like, well no, look at how that stuff fits nicely together. Today, we know that there are tectonic plates underneath our feet that are constantly moving at a slow rate, and scientists can study these things using a variety of methods. Remember how I talked about India? Let's go back in time again. Boom. 250 million years ago. There's Pangaea. To put this in perspective, you would have to watch this science video more than 13 trillion times. Thank God we don't have to. We also don't have to watch this happening in real time. Stop right there. For reference, that spot of land right there is today's India. Go. Did you see that? Look, it hit modern day Asia. Now the Himalayas are forming. Okay, welcome back. Now we're on our modern Earth again. So all those things bouncing around, that blue stuff, just keep bouncing around? Yep, it's constant. And it's happening right now as we speak? Yep. Let's break down the science. So the Earth is made up of layers, but only two are important for the purposes of this explanation. the mantle and the lithosphere. The mantle is an inner layer of the Earth and ranges in temperature from 1,832 degrees to 6,692 degrees Fahrenheit. The mantle can be divided into a few more layers, but the upper mantle, the one at the top, is responsible for tectonic activity. Most of it is completely solid, but some of it is malleable, and that's where tectonic magic happens. The lithosphere, or the crust, is the outer part of the Earth, which goes down about 62 miles. On the lithosphere, we have 15 tectonic plates which make up Earth. These plates sit on top of a zone called the asthenosphere, which is a stretchy version of the upper mantle. On the sometimes more malleable mantle portion that the lithosphere sits on is where the continental drift can happen. So, at this point it should be noted we've coined this phrase continental drift, which is a bit misleading since the plates don't actually float. The asthenosphere is not a liquid. But at areas where it is more ductile or stretchy, we can observe earthquakes, the formation of mountains, and volcanoes. There are 15 plates on our Earth, forming different kinds of boundaries. At those malleable areas of the mantle, we have been able to mark divides around the world where tectonic activity is more common. We know these are there because of continued advancements in ocean mapping and satellite technology. When these plates move, they move in a lot of different ways along plate boundaries. This can occur in the ocean or on land. In the ocean, plates are subducted, which means that one plate is sucked underneath another plate. This causes the formation of a trench. The Mariana Trench is an example of this type of convergent plate action happening along the Pacific and the Philippine plate. When plate movements occur on land, plates are usually pushed upwards. This happened back when India collided with the Eurasian plates. The final example of what plate motion can go through is a strike-slip fault at transform boundaries. This happens when two plates grind against each other in opposite motions. This occurs very famously at the San Andreas Fault and happens to be the same type of motion occurring now in India. But more about that in a second. To recap again, the Earth is round. 15 plates on Earth, 3 plate motions, convergent, divergent, and transform faults. These can occur on the ocean or on land. Great. So now on to India. According to a recent research letter published in the Geophysical Research Letters publication, India is breaking apart. What makes this interesting is that the split almost comes as a surprise. So usually, oceanic plates are only seismically active along their boundaries, and anything happening in the middle is very rare. Back in 2012, though, a couple of very large earthquakes were observed inside the India-Australia Capricorn Plate, which created a slice along the seafloor. The scientists who recognized this slice noted the similarities the break has with other continental boundary faults, which support the inferences that this plate is breaking apart. Since then, the one Indian plate has been recognized as something like 3 plates that are tied together and moving in the same direction together. These plates, and all the plates on Earth, will continue to move as they have been for millions of years. But don't worry about your 2020 getting any worse. The next earthquake along this area isn't scheduled for another 20,000 years. Oh, and if you want something to really freak you out, check out the most recent earthquakes here.